Hello all. Today we discuss about Laplace transformation. So the importance of Laplace transformation is first to discuss and application in a control system or control engineering. So first of all, our today's topic is Laplace transformation. So Laplace transformation is basically denoted by the S parameter, and from time domain or any other domain signal is converted to time or any other domain signal x and y is converted to the S domain first, and this is the first objective of Laplace transform in a Laplace transform. So Laplace transform for a given signal is given by the formula Laplace transform of ft is equals to 0 to infinity e to the power minus st ft dt. This is a Laplace coefficient, and this ft is a signal time domain, and the integration is a one-sided, that is 0 to infinity. This is called unilateral L dot t, means Laplace transform. Okay, so Laplace transform is denoted by L of any signal is represented by this Laplacian domain, that is Fs. So here F is equal to the Laplace transformation. So first of all, what are the conditions? The signal have some conditions for which we can apply the Laplace transformation. So first of all, signal must be single valued. Signal ft must be single valued. Okay, that is for a particular instant, for a particular any time there is only one amplitude is present. Okay, number B is function ft or signal ft is continuous. This is the very important condition. Third is signal or function ft is a piecewise linear. Okay, D is signal or function ft is the integral value is, that is 0 to infinity, this integration value is must be equal to a finite value, because if this integration value is infinite, then there is a no meaning of to convert the Laplace transformation. Okay, because the answer is ultimately equal to infinity. So this is the basic rules of Laplace transformation. So now we apply for the different signal. There are many types of signals are present in a network analysis and synthesis also, like a filter, like a different types of network, Okay, so now first to introduce about what is delta function. Okay, this is very important. So delta function is also known as impulse function. What is it? That is at t tends to 0, the amplitude equal to 1, that is delta t equal to 1 when t equal to 0, and this is equal to 0 when t equal to otherwise. Okay, and this must be shifted either right hand side or either left hand side. If right hand side, then the shift amount is plus t0 and this is minus t0. So for any one right hand side, the definition of delta t is equals to delta t equal to 1 now at t not equal to 0, that is t equal to t0. Now for this delta t equals to 1 for t equals to minus t0. So this is one separate signal, this is one separate signal. This is called delayed signal, this is called advanced signal. Because why this is called delayed? Because original signal is located at t tends to 0, but in the right hand side this t tends to plus t0, that is the shift amount of t0 in the right hand side. So this is a delayed signal, and this is advanced because this is present in a negative negative cycle or negative time domain, in a negative time domain values. Okay, that's why it is called advanced signal. So first of all, these are delta function. These delta function also denoted by the shifted delta function, are also denoted by del t minus t0 for right hand side, and this is also denoted by del t plus t0. This is for left hand side, this is for left hand side, and this is for right hand side. And student, please noted that this delta function is also known as weighting function. Weighting function we use in a sampling theorem. Then we talk about the concept of weighting function, why delta function is called the weighting function. Okay, so now our next topic is to discuss about unit step function. Okay, this is very important. Unit step function is also known as DC voltage. Okay, because the characteristics is look like that. This is ut, that is ut equals to 1, sorry, this is 1 when t greater than 0 and 0 when t less than 0. So this is a condition of first of unit step function. This is y-axis, this is x-axis. X-axis in a time, this is 0. Okay, so now if this unit step function is shifted by the amount of t0 time, then we say that this function is given by this value ut minus t0. Now if we subtract from this signal from this signal, now here we get one pulse, and we subtract value is ut minus t0. So this is a time period of t0, this is a time period of this pulse signal. So that's why we create one pulse signal, and this is a mathematical equation of this pulse signal. Okay, this is very, very important. Please note down. Third one is very important, which is called single-sided exponential function. Okay, this is very important because single-sided exponential function, that is, this is the value of t time, and this is y, and the function look like that. So y is basically, e to the power minus at for t greater than 0 and 0 when t less than 0, and this value of e is the highest amplitude, and this a is the slope of this graph, and t is the time domain. Okay, so this is called single-sided exponential function. Number 4 is very important, which is known as double-sided exponential. Exp means exponential function. So for double-sided exponential function, there are two axes. For this axis, the value is e to the power minus at, and for this axis, e to the power at. This is a time domain. This is plus infinity, and this tends to minus infinity, and the definition is ft equals to e to the power minus at for t greater than 0 and e to the power at for t less than 0. So these are time domain features. Number 5 is very important. Number 5, note that number 5 is very important, which is also known as constant function. Constant function. So constant function is represented by from minus infinity to plus infinity. For all values of time, the amplitude is constant. So therefore this definition is ft equals to a for minus infinity t to plus infinity. So this is a constant function. Okay, now 6 is very important, known as Signum function. Okay, Signum function is represented by this symbol, this mathematical symbol SGNT, and the function is, this is t greater than 0, this is positive 1, this is negative 1, and this is t less than 0. This is also equal to sign here, and SGNT equal to plus 1 when t greater than 0, and this is minus 1 when t less than 0. Now 7 is very important. RAM signal. This RAM signal application is very much used in a control signals for type 0, type 1, type 2 system on different types of pole 0 configurations and different types of analysis of using this RAM signal. We can measure the stability of the second order and the first order system in a control system engineering. In the later video, in the control system engineering lecture video, we'll discuss about that. And also there is also one mathematical function also uses, that is called the impulse and also unit step function. Okay, so the RAM function is this y equals to t when t greater than equal to 0. This is look like this straight line. This is the value of theta. Okay, now you can measure the slope here also. Okay, the slope is increased as the theta is increases. This is a class 12 concept. Okay, so there are different RAM depending on the slope, but here we just consider there is a slope equal to just 1. Okay, now for the different types of RAM signal, say for this is one here RAM signal from 0 to t, and this is a. So first of all, to express this equation ft, the common form is mx, because this is a straight line passing through the origin, that's why it is y equal to mx. So now what is the value of m? M means y2 minus y1, x2 minus x1. Okay, so what is the value of y2? Y2 here a, and what is y1? 0. Y0 is minimum value 0. What is the value of x2? That is t. And what is the minimum value? That is slope equal to a by t. So now what is the function? Function is a t into this x replaced by t, because this is a domain of t. This is true for t greater than 0. Yes. Okay, but this is for time boundation. The actual condition is it. Now when put here 0, then we see that the value is equal to 0. But when t equals to t, reach here, then the value equal to t by t cancel out, the value is reach here, that is equal to a. So this boundary condition satisfy this equation. Okay, so this is very, very important for the RAM signal. And one thing should be remembered, that first we consider impulse function. Okay, sorry, first we consider here impulse function. So if we take integral of this impulse function, then we get unit step function. Okay, this is very important. And if we further integration of this signal, then we get RAM signal. And for the opposite side, if we differentiate this signal, we get unit step. Okay, and then further we differentiate this signal, we get impulse signal. So this is the inter-mathematical relationship between unit step, RAM and impulse function. Okay, this integrator is also known as, yes, right, low pass filter, and this differentiator is also, yes, right, that is high pass filter. Okay, but this is a time domain approach. In a control system, we see that in a control engineering or in a control system, there are two different domain analysis needed for an electronic circuit to measure the stability, or to measure the different types of peak overshoot, different types of settling, different types of timing features, that is rise time, fall time, delay time, 90% time, 10% time, then settling time is a very important. So in a control system, there are two domain analysis. First of all, one is time domain. So for time domain analysis, we use this integrator differentiator concept. And when we talk about frequency domain concept, then we talk about this filter circuit. Okay, but this is a part of control system. But in this video, we just talk about the signal analysis and the basics of Laplace transform. So this is the part of the student. Please note down. This is the application of the signal and system. Okay. Now we discuss about two very important formula for sine theta and cos theta. Sine theta is also expressed by this expression, e to the power j theta minus e to the power minus j theta by, yes, right, 2j, and cos theta is also expressed by e to the power j theta plus e to the power minus j theta by, yes, right, 2j. So this is very important. Okay, so now what is the formulation of cos hyperbolic theta? This cos hyperbolic theta is expressed by e to the power theta e to the power minus theta by 2. And what is the expression of sine hyperbolic theta? Sine hyperbolic theta is expressed by e to the power theta minus e to the power minus theta by 2. Okay, so this is very, very important. Okay, okay students, one thing should be remembered, that here Laplace transform, this Laplace transform, okay, is applicable for both periodic and aperiodic signal. I again repeat, Laplace transform is applicable for both periodic and aperiodic signal. This is very, very important. Okay, this is very, very important. One is periodic and another is aperiodic. This is very important. Please note down. For a periodic signal, there is a one formulation of Laplace transform, and aperiodic, the formulation is Laplace transform of ft. We talk about that. 0 to infinity ft e to the power minus st dt. Okay, this is very, very important. Okay, in the next slide we discuss about the what is the Laplace transform of periodic signal. So now we talk about the very important part of the Laplace transform. First of all, what is S? This is Laplace parameter S. This S is divided in two parts. One is sigma, this is called attenuation constant, and this is called omega, that is frequency domain. Now if we plot this domain, then there is a plus sigma and minus sigma, and this is minus j omega, and this is plus j omega. Now if we consider the signal with no attenuation, but in a real communication system or control, this is not a practical, there is no practical meaning without any attenuation. So signal with no attenuation means sigma equal to 0, because this sigma equal to known as, yes, attenuation constant. Then if we consider the ideal signal, that is sigma equal to 0, then vanish this axis, then only there exist these two axes is 0, this is minus omega and this is plus omega. Okay, now this is the concept of Fourier transform. So when A is equal to j omega, so this Laplace transform formula L equal to ft is converted to 0 to infinity, but here minus infinity, because the negative frequency to positive frequency. Ft here, instead of s we put j omega and this is dt, and instead of this we write Fourier transform of ft. So in this process we convert Laplace transform to Fourier transform, and this Fourier transform is applicable only for, yeah, right, that is aperiodic signal. Okay, this is very important, aperiodic signal. There are two different types of Fourier transform are available. One is continuous time Fourier transform, that is applicable for analog signal processing and also known as continuous signal processing. And number two is, yeah, right, that is DTFT, that is discrete time Fourier transform. This is also known as DSP, that is this application, this DTFT is application in digital signal processing. Okay, so these two methods are very important. One is CTFT, continuous time Fourier transform, and discrete time Fourier transform. This discrete time Fourier transform and also known as discrete Fourier transform, DFT. Okay, and there is another method which is known as fast Fourier transform, FFT. So lots of topics are discussed in to analyze the signal system and to analyze the waveform analysis, to analyze the waveform analysis also. Okay, this is very important, this is very important. So that's why we discuss in this lecture. So now you can come back in a, so last topic is periodic, aperiodic and sine theta cos theta into the terms of exponential term, and we talk about impulse, unit step, and then ramp function. Okay, now we talk about one another signal which is called radio frequency signal. This is very important for communication standardization. Radio frequency signal is basically, just consider this ft, this consider or expressed by this mathematical relationship. What is the nature of this e to the power at? Yeah, and we know that in a sine theta there is a two envelope, one is +1, that is in -1, another is -1. So there are two exponential are created, one is +1 and one is -1. This is a zero value, and here the sine wave is modulated like this. So after sine time it is, yeah, right, that is, it is decrease in amplitude. So this is the mathematical term of radio frequency signal, because in a media, in an electromagnetic media, there are different types of media exist. Okay, that is conducting media, another is non-conducting media, number 3 is isotropic media, number 4 is dielectric media. So in a different type of media, the amplitude of the electromagnetic wave is decreased or equal to the same as the another as the when the electromagnetic wave travel from one media to another media, there is no change in amplitude also. So that's why this radio frequency signal, the ideal characteristics is expressed by this mathematical relationship. Okay, so our next topic is to discuss about the very important concept in a signal system, that is called the periodic. We express the mathematical equation of this periodic. This is basically our ideal square wave for 0 to t by 2. This is t and this is amplitude a. So the mathematical equation is this, and 0 for t by 2 to t. Okay, this is a positive value. These all time are positives. So this is known as the ideal square wave. Okay, with 50% duty cycle. This is high time. Yeah, that is low time, and the duty cycle is given by the formula t high divided by t high plus t low into 100%. And when this is equal to 50%, this is the characteristics of square wave, and when this is 25%, this is the characteristics of, yeah, right, that is ideal pulse wave. Okay, now our next topic is to discuss about the different signal pattern. Okay, this topic is also known as application. Okay, now talk about, now this is one signal, say this is 0 to t by 2 and this is t. Just consider here, this is 0 to t by 2 and this is t. The amplitude equal to a. Okay, so now look here, there are two signals associated with each, that is, this is ramp, just to consider, and this is unit step. So first of all, we break down two signal y1 t and we express then y2 t. Okay, so for y1 t, for what is the slope? Yeah, what is the slope? M equal to a by minus 0 divided by t by 2 minus 0, that is 2a by t. Yes, right, and the time boundation is 0 to t by 2, and here mention the time domain t, because this is the time domain t. Just the value, just putting the value 0 here, that is equal to 0, and when you put t by 2, that is t cancel out, 2 cancel out, that is it reaches value the value equal to a. Now what is the function of this? this is starting from t by 2 and end to t. So now this is value equals to only just constant a, because this is the only magnitude a, there is no variation because this is a constant function. Okay, so this is the mathematical expression of this above signal. One another signal also discuss here. Now for this signal, consider this is 0 to t by 2, this is t, and this is 3t by 4, sorry, and this is t. Okay, this is a. So there are three part. First of y1t, then y2t, then y3t. So in the first part, again this is 2a t by t for 0 less than t by 2, and this is a constant starting from t by 2 and ending time is 3t by 4. And now this is the negative slope. So here the slope equals to, the negative slope means, this is very important, that is a minus 0, a minus of 3t by 4, and this, that is from t minus 3t by 4, that is t by 4 minus sign here, that is 4a by t into t, but the limit is 3t by 4 to t. So now when you put here 3t by 4, then 4 cancel out. Okay, then tt cancel out. So what is the value? 3a. But in this, but at this time the amplitude equal to a, but here equal to, so and this is a minus, that is just we put here, just we put this value here, 3t by 4, tt cancel out, 4 cancel out, that is minus 3a, but at 3t by 4 this is plus a. So we add up extra amplitude with this signal, that is plus 4a. Now when we put the value of t, that is t cancel out, minus 4a plus 4a, that is the value reached to, yeah, right, 0. So this is very important. Okay, this is the signal analysis for this signal. Okay, now we discuss about very important for Laplace transform, that is Laplace transform for periodic signal. Okay, this is very important. Just consider this is an periodic signal. Here I consider square wave. This is an ideal square wave. This is 0 to t by 2 to t and so on, and the amplitude is plus a to, yeah, that is minus a. So what is the mathematical expression of this waveform? First of all, one thing should be remembered, that here we apply time shifting property. What is the time shifting property? That is, if any signal ft represent at t equal to 0, then f t minus t0 is present at t equal to plus t0, and f t plus t0 is the signal represent at t equal to, yeah, that is minus t0. So here we apply the principle of periodic signal. How periodic signal, for the periodic signal we formulate or we calculate the mathematical formulation of Laplace transform. Okay, so first of all, consider this signal is named as ft. Okay, now just consider the Laplace transform. This is t, the complete one time period or one complete cycle, and for this time period t plus t by 2, that is, this is 3t by 2, this is 2t, and so on. Okay, up to this infinity. Okay, sorry. Okay, so now we apply the formula of Laplace transform first. So first signal, what is the signal limitation, signal boundation, that is 0 to t by 2, this is plus a, and t by 2 to t, this is minus a. Okay, so what is the definition of this signal? The definition of this signal is if t equal to plus a for 0 to, for one complete cycle only, and this is t by 2 to up to tends to t. So this is the two different value for two different time periods. So first of all, we consider here for 0 to t, this ft means equal to a e to the power minus st dt, and for the second signal, the 2t t to 2t e to the power minus st dt plus dot 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 e to the power nt, sorry, this is n minus 1t to nt e to the power minus st, yeah, right, that is dt. Okay, so now this is 0 to t e to the power minus st dt, and if we apply time shifting property here, then this is sorry a here, and one extra part is coming, that is e to the power minus st, because for time shifting, for any signal is time shifting, we know that for the Laplace property there is an extra additional term is present in the exponential form. Okay, so now for the init signal, for the nth time period, the value is nst here, ns into t. Okay, so in between them there is a dot dot. So now a 0 to t e to the power minus st, this part is a common, and in the bracket this term is present, plus dot 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 e to the power minus nst. Yes, right. So now in the upper part, this is 0 to t e to the power minus st dt, and what is the formula? This is 1 plus, these are series of exponential term, that is we write this expression this by this formula. So this is fs, that is the periodic Laplace transform of this periodic signal. This a equal to amplitude, e to the power minus st equal to Laplace coefficient, 0 to t means the complete time period, and this is a 1 minus e to the power minus st here. Okay, so this is the complete mathematical process by which we can convert the Laplace transform formula for the periodic signal here, for that is for the square wave. Okay, so this is very important, and here we apply only 0 to t here. For 0 to t, just only consider the amplitude a. For t to 2t, here also apply the amplitude a. Okay, because all amplitude equal to plus a, and peak to peak value equals to 2a. Okay, so this is the mathematical formula of Laplace transform of periodic signal.